Next question is, for what values of x the numbers minus 2 by 7, x minus 7 by 2 are in GP? See, here we have to find the value of x so that given sequence is in GP. Okay. So here as I mentioned before, that is in geometric progression definition. See, when we can say the given sequence is in GP, that is the every ratio, that means second term divided by first term, that should be equal to third term divided by second term, right? So here second term, see, given sequence is minus 2 by 7, x minus 7 by 2. Okay. If it is in GP, we can say, see, second term divided by first term, that is equal to third term divided by second term. That is the definition of GP, right? Geometric progression. So if it is in GP, second term divided by, that is x divided by minus 2 by 7 is equal to third term, that is minus 7 by 2 divided by x. Okay, let us simplify this one. See here, denominator of denominator will come to numerator, that is 7x divided by minus 2 is equal to, here denominator of numerator will come to denominator. So minus 7 divided by 2x. Now let us cross multiply this. This implies 7x into 2x, 14x square. Here minus minus will cancel, right? Okay, in both sides minus are there, so it will cancel. So 2 into 7, 14. Okay, that implies 14 will cancel, so x square is equal to 1. That implies x is equal to plus or minus. So for what values of x these numbers are in GP? Plus 1 or minus 1. Okay, two values are there. Next question, it is based on sum in GP. How many terms of GP, 3, 3 square, 3 cube, etc. are needed to give the sum 120? See here, how many terms should be added to get 120? Okay, so we have to find the n, that is how many numbers, that is how many terms should be added to get 120. See, given GP, it is the given sequence is in GP, that is given. Okay, see how many terms of GP, it is in GP, 3, 3 square, 3 cube. So how many terms should be added to get 120? So here for that, okay, first we will write what is given. See, it is a GP, it is in GP. So first term is A, that is first term is 3, and what is the ratio? Common ratio 3 square by 3, or you can find by, see, 3 cube by 3 square. Okay, third term divided by second term, or second term divided by first term. So that is 3. Okay. So A is equal to 3, R is equal to 3. Now here, see, first of all, we will write the sum to n terms in GP. Sn is equal to A into R raised to n minus 1 divided by R minus 1. Here R is greater than 1. When R is greater than 1. Okay. Now here, let us substitute. A is equal to, see what is the sum? Sum is given 120. Okay. Here we have to find n. Okay, so 120, sum is given 120, A is 3, 3 into R is 3, 3 raised to n minus 1 divided by R is 3, 3 minus 1, 2. Okay, next, see 3 by 2, take this 3 by 2 left side, so it will be 120 into, when we take this to left side, it will become its reciprocal. Okay, so 120 into 2 by 3. Okay, 2 by 3. That is equal to 3 raised to n minus 1. So this will become, see, 3 4s are, so 40. 40 into 2, 80. 80 is equal to 3 raised to n minus 1. That implies take minus 1 left side. So it will become 81 is equal to 3 raised to n. We know that 81 is nothing but, see, how can we write it in power of 3? 81 is nothing but 3 raised to 4, right? So 3 raised to 4, that is equal to 3 raised to n. That implies n is equal to 4. Okay. See, we have already studied a raised to p. If a raised to p is equal to a raised to q, then that implies p is equal to q. Okay. So here n is equal to 4. So 4 terms should be added. Here 4 terms should be added to get 120. Okay. Next question. The sum of first 3 terms of a GP is 16 and the sum of the next 3 terms is 128. Determine the first term, the common ratio and the sum to n terms of the GP. Okay. The sum of first 3 terms of a GP is 16. Okay. First 3 terms. After C and the sum of next 3 terms is 128. So first of all, let us take, let A be the first term, A be the first term and R be the common ratio. Okay. So see here, what is the condition? First, the sum of first 3 terms. So what are the 3 terms in GP? If A is the first term and R is the common ratio. So sum of first 3 terms is, first term is A plus second term is AR, isn't it? Plus third term is AR square, that is equal to, it is given the sum of first 3 terms of a GP is 16. So it is equal to 16. See, we can write it as A into, see, 3 terms, okay, A is common. So let us take it out. A into 1 plus R square is equal to 16. Okay. See, next condition is the sum of the next 3 terms. That is, here it is first 3 terms AR square, next 3 terms AR cube plus AR raised to 4 plus AR raised to 5. Okay. The sum of next 3 terms is 128. See here also, see, AR cube is common, right? See, in all these 3 terms, AR cube is common. So let us take AR cube outside. So AR cube into, here 1, here, see, if AR cube is out, okay, taken, then remaining R, isn't it? See, if a term taking in outside means dividing, okay, dividing by that term, that is AR raised to 4, taking a term that is AR cube, okay, AR cube, that is AR raised to 4 divided by AR cube, that is equal to R. A cancelled, R cube cancelled, remaining R. Okay, so R plus R square. Here AR cube is cancelled. Okay, dividing AR cube, dividing by AR cube. Okay, taking a term outside means dividing by that term. Okay, so AR raised to 5 divided by AR cube, that is equal to AA cancelled, R cube cancelled. So remaining is R square. That is equal to 128. Okay, now here, see, A into 1 plus R square is equal to 16. See, here also the same term, A into 1 plus R square. So we can substitute this to here. Okay, see, I will write A into this one, okay, equation, second equation, I can write A into 1 plus R square, okay, into R cube is equal to 128. Okay. See, here we have A into 1 plus R square is nothing but 16. That is, it is 16 R cube is equal to 128. That implies R cube is equal to 128 divided by 16. That is equal to 8. Okay, so we have got R cube is equal to 8. That is R is equal to, R cube is equal to 8 how can we write? 2 cube, right? 2 cube. So this implies r is equal to 2. So we have got r is equal to 2. So next we have to find, see what is our question? Determine the first term, common ratio and the sum to n terms. Okay, to find the sum to n terms, we should know first term and common ratio. Now we have got common ratio. Next we will find first term. Okay, I will rub it off. Okay, our question is find the first term, common ratio and sum to n terms of the GP. Okay, so here we have got common ratio, that is 2. Next we will find first term. See, we can substitute this r is equal to 2 in equation 1. We will get a, isn't it? So equation 1 gives a into 1 plus r is 2, 2 plus 2 square, that is equal to 16. That implies 2 square, okay? 2 square, 4, 4 plus 2, 6, 6 plus 1, 7. So 7a is equal to 16. That is a is equal to 16 divided by 7. Okay. Now we have got first term also. Next, our question is find the sum to n terms of the GP. Okay. So what is the formula? Sn is equal to a into r raised to n minus 1 divided by r minus 1. Okay. That is equal to, what is a? 16 by 7 into r raised to n, that is 2 raised to n minus 1 divided by r is nothing but 2, okay, 2 minus 1. That is 16 by 7, 2 minus 1, 1 itself. So 2 raised to n minus 1, okay. So 16 by 7 into 2 raised to n minus 1 is the sum to n terms of the GP. So our next question, the sum of some terms of GP is 315, whose first term and common ratio are 5 and 2 respectively. Find the last term and the number of terms. Okay. See, here it is not mentioned how many terms. Okay. Here sum of some terms. It is given that sum of some terms of GP is 315. We don't know how many terms are there. To whose first term and common ratios are given. Okay. So here we have to find what is the last term and how many terms are there. That is number of terms. Okay, first we will write common ratio, first term, that is a is equal to 5 and common ratio r is equal to 2. Okay, so next we will write the formula for the sum to n terms. Okay, in GP. Sum to n terms in GP. It is in GP. Okay, so don't be confused. See, it is given, it is in GP, therefore write the formula of sum to n terms in GP. Sn is equal to a into r raised to n minus 1 divided by r minus 1. Here r greater than 1. Okay, so here it is given 315. We will find n. Okay, so how many numbers are there? So we will find n here. So substitute what is the sum. That is 315, okay, sum is 315, that is equal to a is 5 into 2 raised to n minus 1 divided by 2 minus 1, okay, that is equal to 5 into 2 raised to n minus 1. 2 minus 1 is 1 itself. Okay, now see here we have got 5 into 2 raised to n minus 1 is equal to 315, isn't it? So here let us simplify. 5 into 2 raised to n, 5 into 2 raised to n minus 5, okay, that is equal to 315. That implies take minus 5 right side. So it will become 5 into 2 raised to n is equal to 320. Then that implies 2 raised to n is equal to, take 5 right side. So divided by, so 320 divided by 5 is equal to 5 6 are 30, 5 4s. Okay. See here we have got 2 raised to n is equal to 64. 2 raised to n is equal to 64. See how can we write 64 in power of 2? We know that yes, 2 raised to 6 is 64, right? So 2 raised to n is equal to 2 raised to 6. 2 raised to 6 is 64, right? Okay. That implies n is equal to 6. See here we have got n is equal to 6. That means there are 6 terms in this GP. Okay. So the sum of these 6 terms is 315. Now our question is find the last term. There are 6 terms, right? So there are 6 terms. So what is the last term? 6th term. That we have to find. 6th term. We have got n is equal to 6. That is number of terms is 6. Okay. N is equal to 6. Now we will find last term, that is 6th term. So A6. Okay. A6 means 6th term. That is equal to A into R raised to 6 minus 1. A is nothing but 5 into R is 2. 2 raised to 5. Okay. So 5 into 2 raised to 4 is 16. 2 raised to 5 is 32. Okay. 32. That implies 5 2s are 10. 5 3s are 15. 16. Okay. So 160 is the last term. Okay. Last term of this GP is 160.